Now we're going to talk a little bit about dividing some rational expressions. As you know from fractions, dividing fractions is very similar to multiplying. To divide two fractions together, we do what we call skip, flip, and multiply. So in other words, every division can be turned into a multiplication of fractions. So that 6 over 25 is to skip, it's going to stay right there. That 18 over 35 is going to be flipped, so it's going to be 35 over 18, and I'm going to multiply instead of dividing. Once I'm here, I can go ahead and do the same thing I was doing with multiplication. Just break the 6 up into factors. Factors of 6 are 2 and 3. Break the 25 up into factors. Break the 35 into factors. And break the 18 into factors. Alright, let's look for common factors now. I have a factor of 2 in common, and remember the reason I can cancel these is because a 2 on the top and a 2 on the bottom divide out to give me the number 1. Okay? I also have factors of 3 in common, and I have factors of 5 in common. So finally, all I need to do is identify what I have left, and the only things I have left are this factor of 1 times the factor of 7, which is just 7, and on the bottom I have a factor of 5 times the factor of 3, which comes out to 15. So that fraction reduces to 7 over 15. When I have variables in my problem, there's no need to worry. Remember, variables are just numbers that we don't know. So we're still going to use skip, flip, multiply. We're going to leave the 5x over y cubed the same. We're going to multiply instead of divide, but we're going to flip the second fraction. So that's going to be y squared over y squared z over 15x. Once again, I'm looking for common factors here so I can divide. In order to help me see my factors, I'm just going to break this out. 5x is just 5 times x. Y cubed is y times y times y. The y squared z is y times z. And the 15x is just a 15 times an x. So let's look for factors in common that we can cancel out. Well, there's an x in common. There are 2 y's in common, and that 15 has a factor of 5 inside of it, right? Because 5 times 3 is 15. So let me rewrite that 15, just to make it a little bit easier to see, as 3 times 5. So there's a factor of 5 in common. So what I have left here now is going to be my final answer. So my final answer is composed of a z on the top over a y times a 3 on the bottom, which is just 3y. That's it. There are no other factors in common. Alright, the last two were just regular fractions. They were all factors. This one, the only difference about this one is that there's these plus signs in the middle. And if you remember from the last video, these plus signs matter because now we're not working with factors anymore. So we have to factor out those sums. So let's start with the 3y squared at the top. 3y squared is already factored out. That just means 3 times y. On the bottom, that 5y squared plus y, I see a greatest common factor of y down there, so I'm going to factor that y out. And what happens when I leave that is I have a 5y left plus 1. Okay? I went ahead and I finished factoring that first one. Remember that the second one has to be flipped. So I'm going to flip it over here on the side. And we're going to factor that flipped answer over there. So on the top, that 5y plus 1 has nothing we can factor out. But on the bottom, I see that there's a GCF of y. So I'm going to factor that GCF out. And I have y plus 2 when I do that. Okay. Once again, now we're looking for factors in common in the top and the bottom. So I see that there's a y in common here. Okay. I also see that this 5y plus 1 up here can cancel out with this 5 plus 1 down here. Remember, if it's an entire factor, I can go ahead and do that. Okay. But I also see this y with this y can factor out. I think those are all my factors. So now let me just identify on the top. All I have is a 3 left. On the bottom, I have a y plus 2 left. And remember, if that factor is by itself, you don't need to put parentheses around it. is just 3 over y plus 2. Now let's do this really long one. And before I start factoring this time, let me just flip this really quick. So this problem is going to be x squared minus x minus 42 all over 2x squared minus 13x minus 7 times, because it's a division, so we're going to skip flip multiply. I'm going to flip that second one. That's going to be x squared minus 49 over x squared plus 6x. Okay, we're going to follow the same process we've been following all along. We're going to factor that top polynomial there, and that's just a standard trinomial. If you don't remember how to factor this is a good time to go back and review it. So that x squared minus x minus 42 factors into x plus 6, x minus 7. Okay. This bottom polynomial here, that 2x squared minus 13x minus 7, you can factor that using AC method, Columbia method, square root method, any other method that your teacher may have taught you for that type of polynomial. I'll give you the answer. It factors into 2x plus 1 and x minus 7. Okay. This top polynomial here, that x squared minus 49, is what we call a difference of squares, and it factors into x plus 7, x minus 7. And that bottom polynomial has the greatest common factor of x. So that's all I'm going to factor here. And when I factor it out, I get an x plus 6. So my last step is just to look for common factors and cancel them out. I see an x plus 6 is in common in the top and the bottom, so that cancels out. I also see that an x minus 7 is in common here and here, so I'm going to cancel that out. And just looking around, I don't see anything else in common, so I'm just going to figure out what's left. So I have an x plus 7 left up there with an x minus 7 multiplied by it all over. I have this 2x plus 1, and I have this x. It's just normally convention to put this single x by itself. So that is my final answer right there.